In this lesson, we're going to be taking a look at special right triangles. It's in particular these two triangles that you see up here. Now, ideally, you'd remember these two because they came up in geometry. But if you don't, you're going to want to write this down to your notes because you're going to be coming back to it through this lesson. Now, knowing these exact values is going to allow us to figure out some other things very quickly. It's going to keep us from having to rely on our calculators. So let's actually see how we can use this information. In this problem, we are told that angle C is 60 degrees. We have side A, and we're trying to figure out side B. Now, normally we'd actually need to set up an equation and solve it in order to be able to figure that out, except in this case, there's something a little bit telling about it. The fact that the angle is equal to 60 degrees is very important because remember, one of those triangles that we had before had a 60-degree angle in it. That 60-degree angle is going to let us do this without having to rely on a calculator. And let's go ahead and see how here. So we know that the C is 60. I'll go ahead and write that in there. We know that A is 14. Now, you'll notice that these two triangles are turned the exact same way at the moment. That won't always be the case, but it certainly is the case here. And so that's going to make it easy to see that that 14 correlates to the 1/2 here. All right? So knowing that, that means I can now figure out what side B is. Because what would I have to multiply 1/2 by to get 14? Times what? What do we have to multiply 1/2 by to get 14? Well, if you're not sure, you could actually do like 1/2 x equals 14. Notice I would divide both sides by half, or in other words, multiply both sides by 2. So x would equal 28. So I'm having to multiply this whole thing by 28, which means that I have to do the same to every one of these sides. So if I want to know what this side length is, I'm going to take the 1 from the original 30, 60, 90 triangle that I have over here, and I would multiply it also by 28 because these are similar triangles. I know they're similar because they have similar angles. Notice 60 degrees and 60 degrees, 90 degrees, 90 degrees. That's all we need to know in order to know they're similar. And that means they scale up. So if I do the 1 times the 28, I get, of course, 28. And that would be the length of side B. No calculator needed there. Now later on, we will be seeing problems where you will need to use a calculator. Those are going to be the ones where we don't happen to have it being one of these 30, 60, 90 triangles. If you look in a triangle, a right triangle specifically, and you see an angle of 30 degrees, 45 degrees, or 60 degrees, then that tells you that you should be able to find your answer exactly. Anything else than that in a right triangle, you're going to be breaking out your calculator. Let's go ahead and do another one of those practice problems. So take a look at this one and figure out how would you find the value of C. All right, now the first thing that leaps to my mind here as I'm looking at this is notice the angle. I know that C is 60 degrees. That tells me it's going to be based off of the 30, 60, 90 triangle here because I have that one angle that is in fact the same. All right, so if I know that that angle is going to be the same, then it's just a matter of figuring out what am I multiplying each of those sides by. All right, so I know in this case, this side B is 10. Now notice that side B is 1 in the smaller triangle because I got it all lined up, right? And so 1 times what is 10? Well, obviously that would have to be 10, right? So our big triangle is 10 times bigger than the small one. So then what am I trying to find? Trying to find C. Well, C is over here. That corresponds to this side. So that means I'm going to be taking this one and multiplying it also by 10. So my answer is going to be root 3 over 2 times 10. It's just, I actually want to clean that up a little bit. Well, if I'm going to do root 3 over 2 times 10, a nice easy way to approach that is to turn it into root 3 over 2 times 10 over 1, because anytime we need to multiply fractions, we multiply straight across the top and straight across the bottom, which means we need to have the bottom written in there. So then if I do that multiplication, it gives me 10 times root 3 all over 2. And then you notice the 10 over 2 reduces, so the whole thing would then equal 5 root 3. And so then that is our answer. We could actually just say that our answer is 5 times the square root of 3. All right, we're going to do another one like those. So take a look at this triangle. Which of the special right triangles would it match up with? Yeah, it should still be the 30, 60, 90, because you'll notice here that our angle involved is 30 degrees, and the 30, 60, 90 has a 30-degree angle in it. So those match up, but this one's turned differently. So we're going to have to really think it through as we go through this process. So I want to look and see what's going on with the side that I actually know, which is the 12. Notice the 12 here. Notice that the 12 here is between the 30-degree angle and the 90-degree angle. So when I want to see what side that matches up within the other triangle, I look for the 30-degree angle and the 90-degree angle and what side is between them. And so I can see then that the 12 is coming from the root 3 over 2. So if I want to figure out how to turn the rest of this triangle into this, I need to know what do I multiply root 3 over 2 by in order to get 12. All right, so to solve this, I would go ahead and I'd say multiply by 2 to start with. So we're going to do both sides times 2. That leaves the root 3 on the left-hand side. And on the right side, that gives me 24. And then I had to figure out the x. I could then divide both sides by that root 3. And I would end up finding that I'm multiplying by 24 over the square root of 3. So then if I want to know what x is, I look for what we call that side on this triangle. Notice that's the hypotenuse. So I grab the hypotenuse over here, and the hypotenuse in our 30, 60, 90 triangle there is 1. And so I'm going to have to do the 1 also times the 24 over root 3. And obviously 1 times 24 over root 3 would equal 24 over root 3. So the exact length would be 24 over root 3. Or if you're really getting fancy, remember when we did rationalizing denominators, you could multiply top and bottom here by root 3. And if you did that, you would end up getting 8 root 3. You don't, strictly speaking, have to here in terms of our purposes that we're doing today, but there will come a time when that's going to be an essential step, so just want to remind you of that. In this problem, we're being asked to find the measure of an unknown angle. Now, in order to do that, it means we basically have to recognize what type of triangle this is. And looking at the general shape of the triangle doesn't always help us because they're not necessarily drawn to scale. Now, I know that drives a lot of people crazy, but it really is true because oftentimes, I could say, well, we have this triangle and I drew it freehand. That is not perfect. That is not even a triangle if you look at all the tiny little details about it. So oftentimes our drawings are not going to be perfect, so don't depend on them being that way. Instead, we have to look at the real numbers involved. In this case, we have two numbers that we're actually given here, where we have 36 and 36 as the two leg lengths of our right triangle. We don't know what the hypotenuse is. We do know one other number, although we have to look a little bit more carefully for it, and that is this angle. We see that that's a 90-degree angle, which is good because all the things that we are working with right now rely on it being a right triangle. So you notice that those two leg lengths are the exact same length. Well, if they're both going to be 36 units long, they're both the same. And there's only one of those special right triangles where those two leg lengths are the same, and that is the 45, 45, 90 triangle, where you notice both of them are root 2 over 2. So if a triangle is an isosceles right triangle, that is, these two side lengths are the same, then you are looking at a 45, 45, 90 triangle, and therefore that angle is also 45 degrees. And we know it just because it fits the criteria of this general triangle that we know. So by knowing that triangle, you can look at pictures and actually tell things very quickly that you might not be able to otherwise. Now you notice in that problem that the angle was given this name. It looked like a zero with a line through it. This is not a zero with a line through it. It's actually pronounced theta. It is the Greek letter theta. It is commonly used as a variable name for angles in particular. But you'll often see Greek letters come up a lot in mathematics. They have a lot of very old applications and tradition involved. And so you still do see them come up. So I don't want you to be too shocked by them as you see them there. This one that came up today, well, time to learn. That's called theta. For the last problem that we're going to be looking at out of this set, we're looking at this triangle. And again, we're going to try to figure out what the measure of the unknown angle is. Again, you'll notice it's labeled as theta. But we need to figure out what is the measure of that angle. So again, we need to look and see, does this fit a pattern that we've seen before? Now, first of all, you'll notice that it has a square root of 3 in it. That actually narrows it down quite a bit because in our two special right triangles that we looked at the start here, only one of them includes a root 3 in it. The other one, the 45, 45, 90, includes the square root of 2. And so that would already tell us that we should be looking at the possibility of it being this triangle right here. The question is it really that triangle? Well, we can actually answer that because if I look first at this number, the 1, that's the hypotenuse, right? Well, if I come over here and take a look and see how that connects to the other hypotenuse, I see that that would be multiplying it by 2. I'm now going to take a look at this other side length right here, where that goes from root 3 over 2 to root 3. And yes, that is the same side. It goes between the angle and the right angle, and it goes between an angle and a right angle, and the right angle rather. And so, yes, we can compare those. So the question is, if I multiply root 3 over 2 by 2, do I just get the square root of 3? And the answer is yes, because if you multiply something over 2 by 2, it cancels out those 2's and it just leaves you with the root 3. So what that told us is that this triangle is this triangle just twice as big along each side. But because it is a similar triangle, that means all of its angles are also the same. Because we can scale up all of the side lengths, but the angles will still have the same values. So knowing that, you'll notice that angle theta that we're trying to find here, that is between, let's see, we got our right angle over here, and then it's along the hypotenuse. Okay, so I got my hypotenuse over here on this triangle, and then the one that goes between the hypotenuse and the right angle, it's going to have to be this one, because you notice that this side corresponded with this side. That's how we knew that the root 3 over 2 became root 3. And so then this bottom one is the one that had to become from the 1/2. Notice what that means is that this angle theta here corresponds with the 60 degrees. That means that that angle is in fact then a 60-degree angle. And we know that just by comparing to that original 30, 60, 90 triangle. Now, if this whole deal looks confusing right now because I've drawn all these lines going this way and that, a great way that you could get around this instead is that you could take your original triangle that you were given over here and redraw it in the same direction as your notes show your 30, 60, 90 triangle. And you could start matching up the pieces. And then it just makes it so much easier to look at and be able to tell what that missing angle measure actually is that way.